Alright, let's do a basic example of normal stress. So we have a case where we have a structure where there is an aluminium bar and there is a steel wire that is supporting the aluminium bar. At the end of the bar there is 300 kilograms of weight. The task is to determine the factors for safety to both the steel wire and the aluminium tube when the yield strength of steel is 355 megapascals and the yield strength of aluminium is 180 megapascals. The diameter of the tube, the outer diameter is 30 millimeters and the hole in the center of the tube is 22 millimeters. So firstly, I usually like to have the formulas which we are going to be using in the exercise. So I typically like to write down the basic formulas there. So in this case we have two formulas which we are going to need, the basic formulas. So firstly, the normal stress, sigma, is normal force divided by cross-section area. And then the factor of safety, N, is sigma critical divided by sigma allowed. Well, in this example, sigma critical, this is the yield strength. Of the material. And this is the value which we calculate in this task. So, stress in the structure. Alright, those are the base formulas which we're gonna need. So let's start the task. So first thing, I always start, and in quite many cases we always start with the free body diagram, FBD. So let's do it in here. So we have the wire, it's pulling that way, force in there. Then we have the mass, it's pulling this way. And finally, in here, we have a force on the aluminium tube. And between these, there is an angle, alpha, right? So let's name these force W, W for wire, force T, T for tube, and then there is finally this external force, which is 300 kilograms multiplied by Earth gravity, 9.81 meters per second squared, which is 2,943. 3 newtons. So here we have the free body diagram. Then one thing which we need to solve in this task is the angle alpha in order to be then able to calculate the forces. So the alpha in this case, well, you should know the basic trigonometry. So when we have triangle, with 90 degrees corner in here. We can call this C, this is B, side B, this is side A, and here is an angle, alpha. So the angle alpha would be tangent alpha is A divided by B. So in this example, our A is 1 meter from the task, from here, and our B is 2 meters, so we can easily calculate now the angle. So basically alpha equals to arcus tangent 1 divided by 2. And it equals to 26.6 degrees. So now we have the information which we need at the beginning. So now we can solve the forces. So you know from mechanics course that the basic things which we do is we do the equations. So we do the equations that the sum of all forces in horizontal direction is equal to 0, sum of all the forces in vertical direction equals 0. And now we can create those formulas. So in this case, the horizontal forces are Ft, it's pointing to positive direction, Ft plus F wire multiplied by cosine 26.6. So Fw times cosine 26.6, that is the vertical component of the Fw, and these are all the horizontal forces, and this has to be equal to 0. We call this equation number 1 in this case. And then all the vertical forces, so we have the Fw. Once again, now we take the the previous one was horizontal. Now we take the vertical component. So Fw times sine 26.6 degrees and minus the external force F equals to 0. And this is our equation number 2. And from these two equations we can easily now solve out the forces. So in this case the equation number 2 is the one that gives us the easiest way to solve this. So I like to mark it like this. So I mark here number 2, meaning that from equation 2 I'll solve the Fw, and the Fw solved from that equation is Fw equals to, we move the F to the other side, so F, and then we divide it by sine 26.6 degrees. And the answer will be 6,573. 6,573 newtons. Alright, so now we have solved the Fw, and now we can easily solve from the equation number 1 also the Ft. So from equation 1, Ft equals to minus, so we move this to the other side, so minus Fw, so we insert this value there, minus 6,573 newtons multiplied by cosine 26.6 degrees, which equals to minus 5,877. Minus 5,877 newtons. So now we have calculated both forces. Let's highlight those forces so it's easier to follow up. So let's highlight those. So these are the two forces. So the first one is the force on wire and the second one is the force on tube. Now we can easily calculate the stresses. So I make a little line in here. So stresses So first let's start from the wire. So sigma for the wire is the force F wire divided by the cross section area of the wire equals to 6,573 newtons divided by cross section area of the wire. And the diameter of the wire was 6 millimeters, so pi times 3 millimeters squared times millimeters squared, like that, and that equals to 232 megapascals. And now we can easily solve the factor for safety. So now the NW is the yield strength of the steel wire was 355 megapascals divided by the stress, which we just calculated, so 232 megapascals. Megapascals will be subtracted away and we are left with value of 1.5. So that is our safety factor for the strength of the wire. So how do we understand the safety factor? Well, basically it means that we could increase the stress in the wire by a factor of 1.5, and at that point we would be at the yield value of the material. And then we can do the same thing for the tube. Sigma tube is F force on the tube divided by cross section area of the tube. And now since it was a tube, we have to do it a bit differently. So the force was minus 5,877 newtons, and the cross-section area on a tube, we calculate that pi times 15 millimeters, so that is the radius, the outer radius from the diameter, the outer diameter, minus the radius powered to 2 of the inner diameter, so 11 squared millimeters squared, like that, and that equals to minus 18 megapascals. And factor for safety tube is yield strength of the aluminium was 180 divided by the stress in the tube, which is minus 18 megapascals, but because factor of safety cannot be negative, we can normalize this like that, and now we get 10. So that's it. That's what was asked for. Determine the factors for safety to both steel wire and aluminium tube. And that's how it's done. Thanks.